Of our polynomial unit today. And we are going to be multiplying polynomials today. Yesterday we did some adding and subtracting. Today we're going to be multiplying those polynomials. Whoops, I don't know why that won't close. Hang on. There we go. Okay, now with the multiplying piece, I want to put this disclaimer out there right away. I'm going to show you 3 different ways to multiply. You need to pick the one you like best. Okay? I am not going to expect that you use all 3 methods. I want to show you 3 different ways, and I'm going to be honest. Some of you are like, Miss Guy, just show us one. Don't confuse me. I'll be honest. It's always pretty well split every year that I teach this, who likes the first method, second method, and third method. So don't just look at the first one and be like, yep, that's the one for me, and block everything else out. Make sure you give all 3 a chance. I'm just going to do an example of each one, give you a chance to try each method, and hopefully by the time we're done today, you've decided which one you like best. Or if not, you're going to have some practice opportunities too. So if we go through one and you're like, oh, yeah, that one was kind of confusing for me, try the next one. Okay, try the next one. All right, so our first method for the multiplying piece says use the distributive property. So what we're going to do is I need to take each term in the first set of parentheses and I need to distribute it to the second. To break this down and to make sure we have the signs right, I'm actually going to break this up into 2 little distributive property situations. So I'm going to take the A from the first set, and I'm going to distribute it to the second set. I'm actually going to take that first term and put it in front of the second set of parentheses. So instead of trying to draw a bunch of arrows, I'm going to separate things out. So I took the first term, wrote it in front of the second set of parentheses. Now I'm going to take the second term. We have to be careful. It's a -1. And I'm going to write it in front of the second set of parentheses. So what I've done is I've just created, instead of having, holy cow, I've got a binomial times a binomial, I've created 2 just smaller distribution cases. So again, I took the first term, my A, and then I wrote it with that second expression in the parentheses. Then I took my second term, which is -1, and wrote it in front of that second expression in the parentheses. Now all I have to do is distribute each thing. Here's where our exponent properties come in. If I have an A times another A, what's my exponent? We're going to get a 2A to the second squared. Remember, when you're multiplying, you have to add the exponents. I know yesterday when we were adding and subtracting, those exponents didn't change, but now we're multiplying. So it's like our last unit. And then I also have to take A times the 5. I'm going to get 5A. So all I did was split it into 2 separate smaller distribution situations. Then we do the second thing. I take -1 times 2A, and I take -1 times 5. So we're just distributing. I broke it apart just to make the process hopefully a little simpler, and hopefully we don't miss signs and miss any terms. Is there anything that I can simplify? Is there anything I can put together? What can I put together? What can I do? The A's, right? I can put the A's together. And I'm going to get 3 A's. And then that's all I can do. I can't put the A's and the 8 squareds together. Those are different. Those are different things. So what I want you to do, I want to see if you can kind of set up number 2 in that same way. I'll come around and help you out. Again, give each method a chance. Give each method a chance. We'll try them all out, and then hopefully by the end you decide what you like best. So when we go to split up, we take the 3n from the first binomial, multiply it times the second, and then we take the -4 from the first binomial and multiply it times the second. So really you're just splitting this up so it's two simpler distribution questions versus, okay, I've got a binomial times a binomial, now what do I do? So basically we're just breaking it into two simpler parts. Distribute. Remember, when you multiply, we have to add the exponents. Watch your sign, guys, on that second piece. It is a -4. It's a -4 you have to distribute. So you've got a -4n and a -4. Just double check your signs. Kind of the same as when we were doing the adding and subtracting yesterday. It's the signs that can get us. Same thing as when we talked about standard form yesterday. It's the signs that can get us. We miss a negative sign, we maybe misadd, or we multiply, we got a negative and should have got a positive. Just be careful with your signs. All right, now we have to look to see if there's any like terms that I can put together. Again, we have those n's. +3, -4. You can write the 1 in front of the n if you want. It's a -1. Remember, mathematicians are lazy. They don't like to write those coefficients of 1. I would never mark it wrong, though, if you have the 1 there. No big deal. All right, so for multiplying two binomials, remember, binomial is two terms. If we're multiplying two binomials together, here's one option for us. Split it into two separate little distribution questions. Then combine any like terms after you multiply. That's one option. Option number 2. Option number 2 can help people stay a little more organized. It's a little bit easier sometimes to set up, or a little more visual for people. What we do is we take our first binomial, the 2w minus 5, and we split it into those first two boxes. We take our first binomial and I put it in those first two boxes. Then I do the same for the second one. I have a w and a -3. So I take my two binomials and I write it in the first one in the first column and one in that first row. Then all I have to do is follow my table to do my multiplying. So I'm going to start with, I'm going to take 2w times w. And actually, let me change my pen color, make this stand out a little more for you guys. I'm going to get 2w squared. So I take the first row times the first column. I get a 2w squared. And then you can work your way around the boxes however you'd like. Next, I'm going to do 2w times -3. And I get -6w. You can work your way through however you want. Maybe you want it to go down before you went across. Then I have -5 times w. -5w. And then I have -5 times -3. I get +15. So for some people, this method with the boxes, it makes things a little more visual and it makes it a little more organized. Makes it a little easier to break down. The only thing is, so on your sheet, I have these boxes drawn for you. If you choose this method, you would just have to take a minute to draw yourself your own little table. And it just kind of looks like a little tic-tac-toe board. It doesn't have to be anything fancier than what I have on the screen right now. So if you do choose that method, there's not going to be little boxes on your practice or your test. You would just have to draw. Again, it's just like a little tic-tac-toe board to fill in from there. So go ahead, if you haven't already, I know sometimes you guys work ahead of me, go ahead and try out number 4. See if this organization method for the multiplying, see if maybe this clicks more for you than the first one, or maybe you're thinking, no, that first one, I'm still liking it better. I'll be around if you need me, guys. Now, guys, I just realized I got ahead of myself. I forgot to actually finish question 3. We need to simplify question 3 like we did the upper 2. I got ahead of myself. I was too worried about, hey, here's how you draw your own boxes. So we finish off question 3 the same way we did 1 and 2. We put together our like terms. So I have a 2w squared. I don't have any other squareds. And then I have a negative 5w and a negative 6w. So I have a negative, my screen's freaking out, sorry guys. I have a negative 11w, and then I just have a plus 15. So make sure you do that to finish up number 4. Sorry guys, I got way ahead of myself, worrying about how you guys draw your own boxes and things. So I'm going to go ahead and set up number 4. I know some of you are just kind of working your way through. Don't forget when you split things apart, I put a lot of negatives in this example on purpose because the negatives are forgotten negative signs. That's where I see the most mistakes when it comes to this. Now I know this one's a little bit different because we don't start with an h squared. You can only multiply together what's there. That first box, I have a 6h and a negative 3. So all I get is a negative 18h. I don't have an h squared. When you multiply, be careful. It might not always be the first term ends up being something squared. It depends on the order of the binomial pieces. Then I have a 6h and a negative 2h. Now I have a negative 12h, and now it's squared because I had an h times an h. So be careful. Don't just automatically assume because on the first 3 we had something squared first that that's always going to be the case. Negative 2 times negative 3 is positive 6. Negative 2 times negative 2 is going to be positive 4h. We talked yesterday about standard form. I want my highest exponent first. Highest exponent first. I can put together negative h and positive 4h. And then I just have a plus 6 all on its own. Double check the order of your answer. I know we just were introduced to standard form yesterday. You got to practice a little bit on assignment 1. But here it comes back again today. So make sure your final answer, highest exponent, would be our 2, followed by a 1, and then essentially a 0 because we don't have an h there. All right, so far, guys, our 2 methods. We split apart our 2 binomials into 2 simpler distribution type questions, or situations, I should say. Our second method, we used a little table to help us organize our multiplication. Our third method is a little acronym method. It's called the FOIL method. The F in FOIL stands for first. The O stands for outside. The I stands for inside. And the L stands for last. And we're going to walk through and talk about what first, outside, inside, last means. We'll talk about what those things mean, but it's a little acronym. And it's our third and final method. So after this one, hopefully you've kind of made your decision about, hey, I really liked method 1. Or hey, those boxes I think are really going to help me stay organized and not forget any of the terms. So here's what this means. Let's take a look at question 5. But question 5 looks a little different. Question 5 looks a little different. Miss Golly, we always had 2 sets of parentheses. Now I have a squared there. So let's think about all our work with exponents. What does it mean to square something? What do you think, guys? What does it mean to square something? Caden, what does it mean? Multiply it by itself. So in question 5, here's what I want to dispel right away. This does not mean, do not write this on your paper. It does not mean I get an x squared, and then I get a 4. I know we saw questions kind of like this last unit, but the questions we saw, there would have been multiplication in the parentheses with the exponent outside. Then we would have done our multiplying thing. This one is different, however, because there's an addition sign. So we have to go with what Caden just told us. What this means, it means the same thing times itself. So if you come across a situation where you have a binomial squared, our power rule from last unit doesn't apply because we're not multiplying or dividing inside the parentheses, we're adding. So we have to take that literal definition of what squared means. It means that thing times itself. Now it looks just like the first 4 we did. So let's talk about FOIL. The first part means we multiply the first 2 terms together. So we're going to multiply x times x. The first 2 terms. So x times x gets me x squared. X times x gets me x squared. The next part of our acronym says outside. So I'm going to take x times the 2. Those are the 2 outermost terms. So O could be outside. Some people say it's outer. It's the 2 outside terms. The terms on the very far left and the very far right. The next piece, the I is for inside. So it's going to be the 2 and the x. The 2 inside terms, so the 2 that are closest to each other. So our 2 in our first binomial and our x in our second. And then the L stands for last. So I want the last term in each binomial. So it's going to be a 2 and the 2. So basically, this is how we would distribute when we just had one thing to worry about and we drew our arrows and made sure we got to each term. And if you draw it, you can kind of see it makes like a little face. Makes kind of a little face. First, outside, inside, last. You should have 4 different terms. That's part of the reason also you have that little acronym. You know it has 4 letters. You should have 4 terms as your end result. Now we simplify what we can, just like all of our other ones. And we make sure we have standard form. Highest exponent to lowest. So go ahead, try out this method. And then we'll kind of check it out together. And hopefully you're kind of deciding, yeah, I think this is what I like best. Now, as you guys were working on this, some of you are like, Miss Golly, this way I think is more confusing than the last way. Or some of you are like, yeah, this is what I'm talking about. I can just draw the arrows like I'm used to for distributing. Then this is the method for you. This is our third and final way. Remember, you don't have to use all 3. Our first terms would give us a z squared. Our outside terms would give us a 2z. Our inside terms would give us a 3z. And our our last terms would give us a 6. Now, if you didn't have that exact order, that's okay. Again, part of the reason with having that acronym with 4 letters is so you know the end result should have 4 terms. Then we simplify from there. We've got a z squared. We have 5 z's plus 6. So now that we've seen the 3 methods, again, my goal for you by the end of those 3, and I know you just got to try each one once, I'm hoping you have some kind of an idea of what you like best. Now, the most complicated we're going to get is how we see our last two questions. We have a binomial, 2 terms, times a trinomial, which is 3 terms. You have to decide what method you like best. So if you like the first method, I'm just going to kind of help you set this first one up. If you like the first method, take your x from the first binomial and then rewrite your trinomial. Then we have our -2 from the binomial times your trinomial. That would be one option. We'll go ahead and go through and distribute to make sure we do okay with our exponents. And then I'll show you how you can use the boxes to set it up. And if you like the arrows, FOIL doesn't fit for this one because we're going to have more than 4 terms. But the idea of distributing, and you can draw the arrows if you want, it can still hold true for this. You just don't have the acronym piece to get you through. Here's where we have to be careful. X times x squared. When we're multiplying, we have to add our exponents. So we do get an x cubed, or an x to the 3rd. I know, guys, it's kind of hard to switch gears. Yesterday, adding and subtracting, exponents didn't change. Now we're bouncing back to we're multiplying, so we have to add the exponents. I know we've got to get used to it, and we will. We will with practice. X times x is going to get us an x squared. X times -1. You can put -1x if you want, or you can just put -x. Up to you. And then you do your second set. We're going to get a -2x squared. We're going to get a -2x. And a +2. So again, this is like our first method. I took the x from the binomial. I took the x from the binomial and distributed it to the trinomial. I took the -2 from the binomial and I distributed it to the trinomial. So the x comes from my binomial and then the trinomial is still in parentheses. My -2 comes from the binomial and then my trinomial is just in parentheses. So all you've done is taken that first binomial and you've split it apart. And you're showing yourself multiplying, distributing each part to that trinomial. All right, so we've got to put our like terms together. I only have an x to the 3rd. I've got a +x squared and a -2x squared. So we're going to get a -x squared. -x, -2x, -3x. And a +2. And a +2. If you like the boxes, you just have to put one more line on there. So you can do your x and -2, x squared, x, and -1. So if you want to do the boxes, you can. You just have to add an extra column on to account for the extra piece of the trinomial. And then just go through and do your multiplying. And if you liked the FOIL method, we can't use FOIL here because, as you can see, we ended up with 1, 2, 3, 4, 5, 6 terms after we multiplied. So FOIL runs out after 4 terms. But if you want to, you can show yourself without splitting it apart. You can show yourself distributing that x to the trinomial. If you don't want to split it apart, you don't have to. Splitting it apart like we did here, though, that helps me not miss signs. It helps me not miss terms. And then you'd have to do the same thing and distribute the -2 to that trinomial as well. So take your pick. Take your pick on the method. Try out question 8. Take your pick Try out question 8. Your choice, 100% your choice. You can choose whatever method you like, guys. I'm just going to go up here. I'm just going to write the 6 terms you should start with. You might not have them in the same order that I do, and that's okay. When we get to our final answer, that's where we should match. So all I have up here right now, no matter which method you chose, these are the 6 terms you should get after you multiply. Before anything is simplified, before we worry about standard form, double check your signs, double check your coefficients. Then go ahead and start putting together those like terms. Then start to worry about highest exponent to lowest. So up on the screen, I do have the final answer. I'll be around if you have questions. I'm also going to drop off your second assignment to you, so when you're ready, you can dig in.